In this screencast, we're going to look at some ways of processing data. This happens to be for a Moberg EEG recording that has both EEG and physiological data, exporting that data to CSV, and getting some of that in a higher resolution that would normally be done for CSV data, and also batch automating some of that processing as well. This is Michael Guest, VP of Research and Clinical Applications for Persist. Let's go ahead and open the recording. This one has not been processed yet. There's a lay file there, but and XML file for some trend settings. But really, this is the Moberg recording. This is what comprises it here. So what we're going to do is go ahead, and once we've opened this, is I've already got a trend panel set up. This comprehensive trend panel where I've added physiological parameters. And to create the panel that we were looking at previously, I'll bring that up in a moment. What I did was I duplicated this panel and then renamed it to what I wanted, which is the physio only, and I deleted those other trends. It deletes them from the panel, it doesn't delete them from being calculated. So I have a panel here of just the physiological stuff. So since that's already calculated, Persist doesn't have to calculate that again. Let's go ahead and see what happens when I hit the process button here. And this trend template, I used a modified default trend template for P14 and added these trends for ICP, CPP, MAP, heart rate, and CO2. And I have a versus baseline for heart rate that I haven't populated yet with a baseline. But aside from all that, the main thing to note is that right away, these trends get plotted. So even though it's calculating artifact reduction and so forth, we've got a significant amount of artifact in some channels here. I can put on a custom, I created a 75 hertz band stop, attenuates it a bit more. But the artifact reduction really helps separate some of that quantization error, at least in this particular recording, to be able to see the underlying signal. Aside from that, though, these are calculated right, or these are displayed right away because they're already calculated. They're already part of the recording file. So let's take a closer look and see what we have here. If we go ahead and show trends only, and I'm going to change the time base here to a minute. And we can see the epochs, the blocks of epochs of doing the EEG calculations. But look at the ICP here. This is pretty high resolution. This is has a fairly high sampling rate. Go along because we can see that waveform there. And the same thing with in tidal CO2. We can see all that playing out at fairly high resolution. We're just looking at 60 seconds here. And CPP, MAP, heart rate, those are at lower rates for that data. And as it happens, you can export the high sampling rate CO2 and ICP, but you have to do those individually. So let me just switch that panel where I had the physio only. Now if I were to export all of these, and to do that I could hold down the shift key and highlight the bars on the left, and I'll put it in a range so I'd end up with a really long CSV file. To do that, I'm just going to click Insert Range and put a range in. So this is 43 seconds, and I'm going to go to Tools, Export Channel Trend Values, and I'll just drop this on the desktop for now. Patient.csv, save. Okay, so I've saved that, and let me pause this for a minute while I pull up Excel to show what it looks like in a spreadsheet. And there it is. This is actually running outside the virtual machine, so just sitting there on top of the window. Hopefully it shows up. So here's my clock date. That's Microsoft OLE time. Get into that if need to be. We can discuss that through web conference. Here's the time. This is the elapsed time we want to look at. And so what we have here are the data for each one of these outputs. And what we can see here is that we don't have a really high sampling rate for this. So 130, 131, 132, 133. So this is going by 1 second. And so that's fine for the mean arterial pressure, heart rate, CPP, which is a calculated value, that's fine. But the ICP and the CO2 are actually higher resolution waveforms showing up in there. Now this resolution may be fine or not, depending on what you're doing. But if you want to get this out at the resolution of what it was sampled at, let's go ahead and close this. And I'm not going to save that. Let's go ahead and bring this up again. And this time I'm going to select just the ICP. And we're going to go to Tools and Export Channel Trend Values. Go to the desktop. I'm just going to overwrite that one. And we're going to open that up in Excel as well. So here we've exported just the ICP data. And if we look at this, we scroll down, we see this 128 Hertz data in CSV format. So if I highlight this column, and we go ahead and we just grab a line graph of this real quick. There it is. So it's showing all the waveforms there, or all the deflections of that waveform in higher resolution. So that's a way to get the higher resolution CSV data out for a particular trend. So normally 1 second, and again, there's often a limit to how big you want a CSV file to grow, and for an entire recording that might be pretty large. But if you want the higher resolution data, and I put in a range here just to limit what we were exporting, but if I didn't put a range in, it would do the whole trend. And we can do that with a CO2 value, and it'll make a very large CSV file. Well, we'll just do this actually because I don't want to make it that enormous. All right, so we're going to do CO2, same thing. I've just highlighted the CO2. We'll go to Tools, Channel, Trend Values, drop this on the desktop. Just overwrite that old one, and we'll get the same thing. And there are the CO2 values. And we can go ahead and make this time column a bit larger. But you can see here that it's a higher resolution. Highlight this, and we can go ahead and draw that out. And there's the CO2 at its native resolution, at least in the trend. So that's how you get the higher resolution stuff out. And of course, it's all elapsed time, so it's time stamped. Now let's look at automating some of this process. So to do that, let's go ahead and process the recording. And to process the recording in a batch file, I'm going to go ahead and bring up this. And just as an aside, when you're trying different settings and so forth, in some earlier versions of P14 and P15, this really won't be as much. Persist will want to carry forward things that you've done previously. So in a normal monitoring case, you want to carry forward notification settings, thresholds, any patient-specific stuff. It's stored under program data, persist, region, patient. When in doubt, if you're reprocessing things with different settings, you can go ahead and just delete the contents of that so it doesn't try to carry anything forward from a previous run, or when you're continuing a processing run, if you want to go at it clean, as it were. So I'm going to go ahead and open that layout file. It's at the top of this list. Or at the bottom of this list, fine. Patient.lay. We're opening it up. So I could just process this, but what I'm going to do is clear the trends. Oh, it's probably open in another window, of course. Yep, I'm going to go ahead and close this. Clear out the trends so we have a fresh start. All right. So once we've done that, I'm going to go ahead and go to my EEG folder here. I've got a process.bat. Let's see what this is. Pretty straightforward. It's going to launch the PSCLI program from Program Files Persist Insight. It's going to process, export the comma separated values from a particular, whatever the default trend panel is. And in that case, it is the physio only one. We can double check that to see what the default trend panel is. And it is indeed physio only. So that's the default panel. We're going to change that in a minute, but it's going to just use the default trend panel. Export the CSV values for that, and this is just telling it what file type and where the file is. So let's run it, and that'll take a little while. So I'm going to pause the recording and restart it here when this is finished processing. Okay, our batch file is completed, and what it did was it processed the recording. And this is the default trend panel, so it did the same as what we did when we exported all of these, except it did the entire time range. And we see ICP, CPP, and so forth, and 1 second epochs. Those are the values. Okay. So let's see how we can get those other values out without having to reprocess it. If we go up here, I've created a couple of batch files. And what these are identical actually to the process file with one difference. So here's the one that processes, and there's a / process. Okay. This one doesn't have that. It just has the export CSV, and I put in panel ICP for that. And what'll happen is when I run this one, it's exporting that. It's going to be a big CSV file. So once that's done, I'll have the values just for that. Okay, that's done. And writing a CSV file that large takes a little while, but much faster than processing. So it didn't process, it just wrote a CSV file from that recording. So I'm going to go ahead and open this up in Excel to see what's in there. And too many rows to fit in Excel, but you can see here this is the high sample rate data, and we can look at the elapsed times there being as small as they are. And of course we can throw a line graph on that as well to see what we get for the ICP. And there it is. Of course we took the whole range, so you can see that it's showing all the various bumps and morphologies that went along with that. So let's go ahead and look at the other batch file, CSV2bat. And if we edit this one just switches the panel to CO2. So now we're going to export the CO2 values. And again, it doesn't have to reprocess. I'm going to close this other command line window. And it's in the process of writing that CSV file. So that's just a few tips and tricks of working with the Moberg physiological data to get the CSV values from the trends with the elapsed times indicated in one of the columns, with the option of exporting high resolution CSV value for those physiological trends as well. With one twist, you want to have a panel with just that trend in it. You don't have to reprocess the whole thing. You don't have to reprocess it at all. You just run a batch file calling out the panel that has those particular values, and it'll write them out. You can see that one's already finished. We can take a look at that, but you can see it's 103K. It's pretty big for one column of data. Anyway, this is Michael Guest, VP of Research and Clinical Applications for Persist. Feel free to email me if you'd like to go through any of these items in detail.